Okay, I'm not finished spunning the coil, copper coil. And as you can see, this is the phase point wires. They're in the bulk. They are a large gauge of a bulk wire. I spun as many stacks over here, as many coils, and what I'm going to do is also align it with one more coil going directly up in one way. So even though I have these in loops, I'm going to do that. And then the following part is using silicon wire, copper wire, and I'm going to wind it around the shoe and ride all the way upward in the same formula what I did at the front to separate the parts so I can get into it, and wind it all the way up to the top. The silicon wire, and then I'm going to use boron steel wire, and I'm going to wind the same thing over. When I do the silicon, I'm going to wrap it 3 times, wind it up, wind it, draw the line down, and wind it up, draw the line down, and wind it up. So what I'm going to do is the base where it gets hot at, it's going to get cold as it dissipates, as it moves to return to the helix and return to the helix. As long as it's being phased by the junction of the copper wire. The boron wire is going to be coupled to the silicon to follow alongside this as far as the metal bond. This is going to operate like a P-type diode and as like a single-phase rectifier. Though I'm going to be using, how is that done? It is similar, like I have something local to me there. I just wanted to show you the shape. Now, it's not a rectifier, but single-phase. But a single-phase rectifier diode has a silicon and a boron end, and being 2 blocks within a cylindrical and current carrying phased by the metal bond to connect to one to another to create a parallel P-type diode just to move one way, and the other side is negative. So N and P, negative and positive, so it doesn't come out the other end. However, doing that, phasing it, where the metal bond reacts as the copper coil, and the silicon local to the surfaces touching the metal bond, receiving a charge, receiving a signal to establish a charge. Then current carrying sending to the boron, and the boron sending out the other electrical energy basic output. So when using the silicon, and I'm not going to be using a metal output or a current carrying source, another coil, I'm just going to wind it upward with the silicon 1, 2, 3, and then with the boron 1, 2 twice. So winding all the way up and winding down. And then what I'm going to do is, since that's going to react as a single-phase rectifier, one type of single-phase rectifier, and the following segment shall be I have to spray this with adhesive and pat it down. The adhesive would enable me to shape the coil windings. Then I will release the bolts and stuff and add on the conductive resin and epoxy, conductive resin, and I'm gonna add epoxy to it and to crystalline to harden it. Once I'm able to do that, then what I'm gonna do is break it free from here, from the surface base, and from the bottom of the shoe, and reduce the rubber. However, the coils I'm going to keep there. I'm going to be cutting around it with a grinder just to get it out. This materials is connected to adhesive tape, and I can take this right off with the hardener. So that's one of the points I'm going to do. The phase points are here, and the following cage for the system. This is another part of the metal bonds, like the execution gate. So enables, it's in a linear motion. It enables the force. So once I do this, it will reduce the size. Now this is the part that goes onto here, and it's supposed to be fixed onto here to cause this aluminum block to lift up in the air. And the cage of the frontal and the back I do have. So I have stacks of these linearies that's going to be in between the cage. These are coil bearings, and I'm going to be placing them evolved into the cage and layering and phasing it, and that's how it's going to sit alongside the aluminum base. So just give me a moment and I'll be right back with you. I'm Jermaine Morton. This is for the self-repulsive ion boot. Goodbye.